Everyone, my name is Harshavardhan. I am from EC department. Today, my topic was the Ampere's law applications, and roll number was 244G1A0442. I am studying in Srinivasa Ramanujam Institute of Technology. Ampere's Ampere circuit law and its applications. Introduction to Ampere circuits law. Ampere circuits law relates the magnetic fields to electric currents that produce them. It is a fundamental principle in electromagnetic discovered by the Henry Ampere. The law helps in calculating the magnetic field for the various current configurations. You have seen the right side of the Ampere circuit's law derivative. Ampere circuit, because it is symmetric, then the magnetic field intensity on one side of the current sheet is negative. Of that the other side, the the above the sheet, Hx is equals to 1 by 2 k by z is less than 0, while below it Hx is 1 by 2 ky, z is greater than 0. And mathematical formulation of the Ampere's law. Ampere's law is expressed in the integral as the line integral of the magnetic field around the closed loop. Mathematical, it is written as point by vector b and the dot vector is equals to multiplication of 0 into enclosed. You have here right side having the definition of the Ampere's law. Ampere's law states that the magnetic field created by an electric current is proportional to the size of the electric current with a constant of proportional equal to the permanent of the free space. The explanation was the consider a straight conductor through in which is current the flow. I flows the magnetic field through below the B generated around the in the face front of the circuit. The magnitude of the magnetic field B depends upon the current and the I distance of between the conductor and the point P where we want to equate the magnetic field. B directly proportional to 1 by R. The combining the both exponential facts B proportional to the 1 by R. Derivation of the Ampere's law. Ampere's law can be derived from the Biot-Savart's law for steady current. It assumes the steady current and the magnetic and magnetostatic conduction. The law simplifies the calculation of magnetic field in symmetrical current and distributions. Ampere's law. Next, we need Ampere's law. We have Ampere's law derivation. In the right side, you need to see if magnetic field is constant on the path. You can symmetric to show the magnetic and the direction are constant. Show that the magnetic direction or constant on the path. Discuss the group explain. Integral b into dl is equals to mu naught of I enclosed. Integral 0 to pi limits, we are applying the limit 0 to 2 pi b enclosed b of cos theta into dl. B into integral 0 to 2 pi dl is equals to b is a constant. We have to outside and 0 to 2 pi into dl. B to 2 pi r is equals to mu naught into I enclosed. B is equals to mu naught I by 2 pi r. Symmetric of simplifications. The symmetric plays a crucial role in the applying the Ampere's law effectively. Some common geometric include the identify include the long strides by the sinusoidal and the toroids. Symmetric assumes only law of a magnetic field be considered as the alone constant along the chosen path. Ampere's law. You have the right thumb rule. You have doing that conducting the wire in single and you have to place the thumb as shown in the figure. Integral b into dl is equals to mu naught into I. Differential form is equals to delta cross b is equals to mu naught into j bar. I is equals to electric current and B is equals to magnetic field and mu naught is equals to permeability of a free space. J is equals to current density. The thumb points in the direction of the electric current fingers. Applications of infinite line current carrying the wire. The magnetic field around the infinite wire circular constant with a wire using the Ampere's law. The magnetic field magnitude B is equals to fraction by multiplication 0 by 2 pi r. B. The field decreases with the distance from the following an inverse relationship. Application sound. A sound a coil wire with a floating nearly uniform magnetic field inside. Ampere's law helps in the magnetic field inside a long solenoid. B is equals to ml0 by pi, where the magnetic field outside the solenoid is negligible in the length of the much the greater than the radius. Application of steroids. Steroids are a circular path considered magnetic field within their core. Ampere's law indicates the magnetic field is proportional to the current and the number of turns. The magnetic field of the toroid by B is equals to fraction by n by I 2 into pi r, where r is the radius. Limitations and assumptions. Amperes assumes that the steady current of the magnetic conditions is effectively a time varying field whereas the displacement and current are involved. The law relies on symmetric complex geometric by equating geometric methods. The particular applications of the Ampere's law design electromagnetic problems. Ampere's law applications. It is used in magnetic field calculations for transformers and inductors. The law assists in analyzing the magnetic circuits and designing the magnetic field shield. Conclusion. Ampere circuits are essential for understanding the magnetic field generated by current. It is simplifies the in symmetric current distribution like wires, sinusoids, and toroids. It applies for widespread and in electrical engineering and electromechanical devices and the magnetic field analysis. Thank you.